Welcome, everyone, and thank you for joining us today. My name is Paul Donahue, and I will be your host. We ask that you please keep your device muted during this session, and if you have questions, please direct them to me via the chat function. We'll do our best to answer questions at the end and to follow up with any unanswered questions by email. As I suspect you know, these tech talks have been designed to provide straightforward insights into radio frequency components. We'll discuss some of the related technologies and certainly the extra design and engineering value that is added by a custom manufacturer such as Quantic TRM. To begin today's session, I am once again pleased to introduce Quantic TRM's Chief Technology Officer, Shaun Moore. The author of 2 U.S. patents and numerous white papers and technical articles on passive microwave technologies, Shaun has been with Quantic TRM since the late 1990s, and his passion for the job and for solving problems has only increased over the years, especially when it comes to resolving our customers' design and engineering challenges. So welcome, Shaun. Can you share an overview of today's topic and your objectives for the session?
Yes, thank you, Paul. So today we're going to talk about really microwave hybrids, and we're going to start off by saying, really what is a microwave hybrid? We're then going to run through several different applications using hybrids, and really my goal here is to try to get you thinking as far as to how you can use these very versatile devices. A lot of different applications, could be solved by using one of these devices. We'll wrap it up with a summary, and then we'll go through with some Quantic TRM differentiators.
Okay, so how exactly would you define a microwave hybrid?
Sure. So a microwave hybrid is essentially a 4-port device, which means that there are 2 inputs and 2 outputs to the basic building block. And basically, there are 2 different classes of hybrids. We have the 90-degree hybrid and the 0 and 80-degree hybrid. Sometimes the 0 and 80 hybrid is also referred to as a magic T. A 90-degree hybrid is a symmetrical device, which means that you can turn it over, flip it back and forth, and the input and output relationships will remain constant. Also, that there is a 90-degree phase shift that occurs between the 2 outputs of the hybrid, hence the name 90-degree hybrid. So really what will happen is if you inject a signal into one of the ports, the signal will divide essentially in half by 3 dB out on each one of the ports. One will be at 0-degree phase and one will be at minus 9-degree phase. The 4th port, or the second input, will be isolated from the other input. This can be very useful for a lot of applications, which we'll talk about and going forward. The other hybrid is the 0 and 80 hybrid. This is not symmetrical in that there is a sum and a delta input, and then there are 2 outputs that are either in phase if you're going into the sum port, or they're 180 phase if you're going into the delta port. Both of these devices are reciprocal, and therefore you can use them as combiners. And that is one of the advantages of these components, is that you can use them either going forward or backwards. They're not simply a one direction device that can be used in both directions. So really we have 2 parts here. We have one where we have a single input that creates 2 signals that are 9 degrees apart from each other, regardless of which input that you go into. And the 0 and 80 hybrid, there are either a sum input, which divides power in phase, or you go into the delta port where you divide the power, and those 2 signals are out of phase.
Okay, well, could you tell us a little bit about some of these applications, the way they are used then?
Sure. So the first application, what we're going to talk about, is using a hybrid as a power divider. Very often, if you think about using a Wilkinson-style power divider, which is really the most common, you can go in there and you can divide power very nicely by using a 0 and 80 hybrid. Go into the sum port. Basically, you're from a functionality standpoint, you're going to operate very similar to how you would with the Wilkinson-style power divider. Both outputs will be in phase with each other, and from a functionality standpoint, will behave very similarly. The advantage of using a 0180 hybrid for a power divider application, though, is that if you're talking about a very high power application, or if you have an application where your load impedances are mismatched, a lot of that reflected energy coming back into a power divider can cause a lot of heat dissipation in the isolation resistors of a Wilkinson divider. The beauty of having a 0180 hybrid is that all that energy gets ported back to the delta port when using it as a power divider application. In this case over here, you could put a nice hefty 50 ohm termination on the delta port, and that reflected power differential no longer becomes a thermal problem within the divider itself. So from an application standpoint, using a 0180 hybrid as a power divider is a very good application. In addition, if you don't have a requirement for the phase coming out of the power divider to be equal, you can also use a 90-degree hybrid. A 90-degree hybrid will introduce a phase shift of 90 degrees between your two split signals. But again, the advantage of having that reflected signal coming back over to the unused isolated port still maintains. 90-degree hybrids are typically smaller, as well as having less insertion loss than a 0180 hybrid. And if you don't have the requirement of having to maintain equal phase in a power divider application, a 90-degree hybrid, again, from a power standpoint, very often can be a great solution to get to solving a thermal problem with a Wilkinson style power divider.
Okay, well, you said that this is the first application. How else can these hybrids be used?
Okay, well, the next application is just flipping it around and using it as a power combiner. The 0180 hybrid can be used as an in-phase power divider by terminating the delta port. Again, this is a great application if you have two in-phase signals that you want to combine, where there could be some phase differential between those signals, and all that non-combined energy has to go somewhere. Porting it off to the delta port is a perfect application. If you're combining non-coherent signals, in which case half of that power will be dissipated in the combining network, a 90-degree hybrid is a perfect choice, because what happens there is that, again, with a low loss sort of network, you can go in there, inject it into two signals. The signals will combine and dissipate it between the two outputs. Therefore, you can go ahead and you can terminate one of those signals where you're going to essentially waste half of the energy. And this way here, you can have a very thermal efficient sort of power combining network. A third application here really is if you're combining coherent amplifiers, you need to have a divider combiner network. Now, a 90-degree hybrid in this case is an extremely great solution, because what you could do is if you divide this signal, the two signals coming out of that first dividing hybrid will be 9 degrees out of phase. If you have then two phase matched amplifiers running in parallel, and then if you combine them by flipping the 9-degree hybrid over so that it is a mirror image of the divider, the phase difference of the divider and the combiner will cancel, and then you will have then an in-phase combining situation. This over here, again, from a power combining standpoint, works very well, because then it will very efficiently combine all that energy. And if there is any errors in the phase of the amplifiers, that error will be dropped off to a 50 ohm termination, which can be a very high power handling situation, as opposed to an in-phase Wilkinson style power divider, where the thermal aspects of that combiner can be marginal at best. So really, the advantage here of coming in with a power combining network using a hybrid is that you can take that any non-combined power and port it off to that high power 50 ohm termination. So this, from a thermal standpoint, makes thermal management really work very efficiently in these sorts of systems.
So hybrids can be used as power dividers. They can be used as power combiners. Are there more applications?
Absolutely. And now the next application we're going to talk about is a combiner divider. This is actually essentially a combination of the of the previous two conditions. Both examples that are on the screen here have two inputs where they need to be isolated from each other. So if you take the input of a 90-degree hybrid, one of those two inputs will be isolated from each other. And then you're going to divide that same signal by 3 dB going out in another direction. You can then further split that off into more different splits. Now, the beauty of this is that if you're going from multiple inputs to multiple outputs, you don't have to combine the signal right down to a single output for the combiner. You can actually start to redivide it as soon as you make that initial hybrid. That saves you 3 dB for the power combining loss. So by essentially taking that signal, dividing it right away, and having the other port be isolated, and then when you feed the isolated port, it divides it right away and isolated from the first port. It's kind of a neat trick that allows you to go in there and build a divider combiner network without the additional 3 dB worth of combining loss and having a 2x2 distribution network. And then of course with examples here, we expand that out to a 2x3 network, or the little flat pack on the right, it's a 3x24 network. And again, by doing it that way, we can have essentially a lossless divider slash combiner network that allows for a good distribution of power. And the loss is not any higher in those devices as the nominal split loss from any one of the inputs. So it's a good application of using a hybrid to be able to go ahead and be able to build these distribution networks when you have multiple inputs and multiple outputs. This is especially useful, for example, if you're running redundant local oscillators or redundant clock signals for various applications.
Okay, so you've mentioned networks several times. Can you explain a bit more about that?
Sure. Now, another big application for hybrids are the building blocks for any kind of mode forming networks or beam forming networks. Again, these are the core building blocks that you use for building things like monopulse comparators, some difference networks, or some more complicated networks such as Butler matrices. All of these antenna feed networks really want to have a phase shift element associated with them in order to be able to steer the beam. And a 90 or 180 hybrid naturally has that phase shift associated with it. So this way here, you can very efficiently manipulate the signal and adjust the phase front of your aperture in order to be able to do some beam forming applications. Again, this is the perfect application for this because these are symmetrical devices that allows signals to be transmitted in both directions. Therefore, it can be used as both transmit feed networks as well as receive networks. And you can generate a variety of beams by accomplishing these sorts of phase networks. There are lots of applications here that can really use this phase shift to your advantage and the reciprocal nature of these devices to be able to go through and create various mode forming networks. I said that the three that are on the screen here are really just kind of the tip of the iceberg as far as the sort of possibilities that we can generate with a hybrid as the basic building block.
Well, excellent information as usual, Shaun. Would you like to summarize?
Sure. Basically, these are very versatile devices, and really you can think about them. And part of the reason why I want to talk about this today was really to kind of give you an examples of sorts of things that you may or may not think of as far as to using a hybrid. For example, use them as a power divider. Usually, most people go in there and they think about these sorts of devices. You know, they think about using a power divider. Power combining is a good application for it. Slow loss signal distribution network, so you can go in there, you can divide and combine signals simultaneously. And I think where most people think about hybrids are mode forming networks and beam forming networks are really sort of the things that I think most people tend to think about hybrids going forward. But I think that's really those building blocks are very, very critical. The other thing that I haven't talked about here so far is you can use a 0-180 hybrid as a balun feed network, for example, for antennas. So there are lots of other applications that I haven't discussed here where a hybrid can be used with great success.
Okay, and maybe you could share a little bit about Quantic TRM and some of the differentiators that you think help us to stand out or helps Quantic TRM to stand out in the marketplace.
Sure. So really what we like to do here at Quantic TRM is we like to work with our customers to go through there and make sure that really the solution that you have is really the best for your system so that your end customer gets the best performance possible. We do this through a careful selection of materials, design approaches, making sure that we are working with the correct block diagram, if you will, to make sure that what we end up with really is the best solution for what you need. We also are very much concerned about packaging and environmental requirements. We also are quite happy to go through there and give you the objective evidence to make sure that the part that you're going to receive will meet the requirements in your environment. And also try to think about Quantic TRM as being a solution provider for you. And that solution could be a wide variety of things, whether it's a custom designed part, whether it's taking a fairly standard sort of parting and just testing it differently, whether it's supplying test data for you to make sure that, yes, the part that you're getting will work and perform in your system. That's really what Quantic TRM is here for, to make sure that you're successful in your programs.
Terrific. And we do have time for a question. And one that I received says, I read that despite their flexibility, and as you've discussed, hybrids, I understand, are not the most popular components. Can you explain why this might be true?
Yeah, that's a really good question. I think really at the nut of that really I think is the fact, almost in the name of the hybrid. If you're looking at dividing power, the first thing that pops in your mind is a power divider, and in that case you got to think about the Wilson style power divider or some other sort of divider like that. Rather than thinking about, gee, really what I want to do is I want to divide power. How can I accomplish that? You tend to think about, well, gee, what device is under that name of what I want to do. So for power dividers, you think about Wilson style power dividers. For power combining, again, you start thinking about these in phase sort of devices, whether it be a ring, whether it be a ring or a glycol or any of those other sorts of power combining networks. So I think people in general don't tend to think about what a device does once you get past the name, and not a hybrid can be a very versatile sort of device because it does so many different things, and really the application of it I think is something that really is sort of an unsung device. Most people tend to think about hybrids as being building blocks for beamformers as opposed to some of the other applications where they can be just as effective. Whether it be a power dividing network, power combining network.
Well, thank you for that. And I think in conclusion, the bullets on your screen really sum it up nicely. And if you have additional questions, if you are a customer, we would love to hear from you. You can call our engineering hotline. The number is on your screen, 888-677-6877. There is no cost associated with these conversations. Obviously, if you're one of our sales representatives, field sales representatives, your calls are always welcome. And looking ahead, our next Tech Talk will be on Tuesday, May 28th, and the topic will be Couplers 2.0. Thank you, everyone, and thanks again, Shaun.
Thank you, Paul.